So this is going to serve as notes help, or if you miss class, this is extra. We're talking about matrices. So what you have is basically matrices are a list of numbers that are in brackets, and we have rows and columns. I think rows go horizontally, columns go vertically. Think about Greek lettering, that's the same kind of Greek columns, that's the same kind of thing. And so essentially, what we're going to do is we're going to take and put the coefficients of our variables into the first part of the matrix, and the second part of the matrix are the solutions. Okay, so that's why there's a 1 and a 4 and a 3, -2. And so that is called an augmented matrix. And you make a little mark right here to show the difference between the solutions. And we're going to be able to manipulate this the same way that you can do any kind of system of equations. So just a few examples. Augmented matrix would be 3, -4, 2, -3, and then -6, -5. Okay, and the one thing you got to make sure of is that all of the constants have been moved to the right. So like in this problem, you need to move that 1 over to the right so that it is not to the left of the equal sign. So we'd have a 2, -1, 1, 0. And this would be 1. There is no y, so we'd write a 0. 1 for z, and then 1, once we move this over there, that has to become a 1. And here would be 1, 2, and 0, because there's no z, and 8. Okay, so you just got to make sure of ones like that you get to the right place. You'll notice that in the problems we do, if there are more than 4 variables, they use these little x's. You could also just do A, B, C, D if you'd prefer not to use the little x's or another letter besides X, Y, and Z. So again, going backwards, 5x plus 2y equals 13. -3x plus 1y equals -10, or just y. Same here. If there's a 0, this would be 4x plus 2z equals 8. And this would be y plus z equals 0. 3x minus y minus z equals 7. So one of the things that we want to do is use matrices to solve systems of equations. And you're going to see I have this on each of the slides. And so row operations, you can switch rows. You can replace rows by multiplying. So that would be, for instance, we could take row 1 and multiply it by 2. And so we could write 2, 4, 6. Or multiply it by -2, it'd be -2, -4, -6. Same thing you do when you do elimination. And then the one that's new that when you get good at this will help speed things up, especially on 3x3 matrices, is you can replace the row by the sum of that row and another row. So you can either add 2 rows together, we could add these 2 together and get 5, 1, 5, or we could multiply one of the rows and add it, and that's what I'm going to show you here. So if we were solving here, and we want to get rid of an x, if we were doing this by elimination, we would want to multiply by a value that we could then add the 2 equations to get rid of it. Well, if I multiply the top equation by -4 and then add the equations together, I can make that be a 0. So that's how it looks in notation. -4 times row 1 added to row 2. So you can't see it because I haven't covered it up. That value, -4 times 1, and then we add it to 4. And then -4 times the second value. This value was a 2, added to row 2. So negative 8 and negative 1. And then this was a 3. 4 times, or negative 4 times 3 is negative 12 plus 2. And so you get a 0 here, which helps us because when we do that, we now have negative 9y equals negative 10, which means you know what y is. So it's the same kind of thing you do with elimination. It's probably not faster with a 2 by 3 matrix, but we're going to practice on some of them because they're a little smaller. So let's do one here together. So I want this to be a 0. I know that if I multiply the top row by negative 3 and add it to the second row, I can get a 0. So when I do that, it means I'm just going to rewrite the first row, and I'm going to take negative 3 times this value. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 2 is 6, plus negative 5 is 1, and negative 3 times 2 is negative 6. Negative 6 plus 9 is 3. So by doing that, I know that y equals 3. So you can then stop, bring this out here, and substitute your 3 in and finish solving. But you also can do it the other way. So if I want to eliminate this negative 2, I could multiply the second row by 2 and add it to the first row. So I rewrite the second row because it's already solved. I don't need to change anything. But if I multiply by 2, 2 times 1 is 2, plus negative 2 is 0. 2 times 3 is 6, plus 2 is 8. So now I have x equals 8, y equals 3. So I solved it. I didn't write any variables at all. Solved it. Okay, so let's do another one. Oops, same one, sorry. So when we get it into that form where we have ones and zeros, it's called a row echelon form. That's a Greek. Echelon's Greek. So we want to have zeros because then if everything else is zeros, we have it solved. Okay, we're going to do this one together. So I'm going to first write the matrix. So 4, 3, 11, 1, negative 3, negative 1. Now I can see pretty easily, I can add these two together. And so I'm going to add row 1 to row 2. And that's going to make stuff go away. So if I'm doing that, I leave row 1 as it is. And I add them together and I get 5, 0, 10. Okay, so we added 2 rows. That's a sum. The constant non-zero multiplier was just 1. It wasn't anything else. So another thing that you can do is replace a row by a multiple non-zero of that row, which means I can multiply or divide everything in that row. So I can divide everything in row 2 by 2. So I'm leaving my row 1. So I get 1, 0, 2. That means I know right now x is 2. So with this, it's probably easier to stop and plug in x equals 2 and solve. But I'm going to keep going just so that you can see how to finish solving with the matrix. So now I can use this 1 I'm just looking at that. I don't care about anything else. I can multiply that by -4 and add it to row 1. So if I do that, I rewrite my row 2. I multiply each of these by -4. So I'd have -4, 0, and -8. Sometimes it helps just to write little numbers if you don't want to do it in your head. So I write -4 plus 4, that's 0. This is just 0. 0 plus 3 is 3. -8 plus 11 is 3. Again, I can divide everything or multiply everything in a row. So I have 0, 1, 1. I'm going to divide that by 3. And 1, 0, 2. Now you notice I didn't keep writing the line there, but at the end, that's for sure. So we know y is 1 and x is 2. We already found x is 2. If you want to double check to see if we're right, 8 plus 3y equals 11. Subtract both sides, you get 3y equals 3. So we solved that system. Again, I don't know that it's faster with a 2-variable matrix, but if we have more variables, it certainly is faster. Okay, I'll do another one. So 2, -3, 0, 4, 9, 5. Now, if you were doing this by hand, it's the same thing. What would you do? I'd multiply the top equation by 3 and add it to the bottom equation. So I'm just going to write that. Multiply 3. That should not be a negative. So 3R1 and add it to R2. So if I multiply the top by 3, I can just write little numbers right here. 6, -9, 0. So I'm adding these together. So I rewrite my first, and I add those. So 10, 0, 5. If I divide everything in the second one by 10, I get 1, 0, 1/2. So I just solved for x. Now I want to get rid of this 2 and make that a 0. So I'm going to multiply -2 times row 2, add it to row 1. Again, I'm going to write my -2 times row 2 right underneath it. So -2, 0, -1. So I'm just adding up. That one's already solved. Don't mess with it. -2 plus 2 is 0. 0 plus -3 is -3. -1 plus 0 is -1. Divide everything in that row by -3. And I get 1, 1/3. I already had this one solved, so I don't need to do anything. So my solutions would be y equals 1/3, x equals 1/2. So that's how you solve with the matrix. We will talk about that. These are some overall hints. Write the matrix, perform row operations. This is all like repeating everything until you get it into that row echelon form. This is Johann Carl Friedrich Gauss. He's the one who invented this. He's did a lot of things in mathematics. Okay, so you're going to work on the exit ticket and turn that into your teacher. And this is just some row operations. And then at the end, if you think you can solve it, go ahead and solve it.